In this example, for test for independence, we're going to look at the data. We're going to look at the raw data and generate the table ourselves. In the previous example, the table was given. The observed frequencies were given in the problem, and we started out from there. But now, we're going to look at this data from Bureau of Labor Statistics. So we have the region of the country and the unemployment rate in that region. Okay, this is a metropolitan area, okay, from different regions. So we're going to look at the unemployment data. And this is from Bureau of Labor Statistics. This is unemployment rate for major metropolitan areas in different parts of the country. So we have the region to which the metropolitan area belongs and the corresponding unemployment rate. So we want to test whether our null hypothesis is metropolitan unemployment rate is independent of the region. The alternative is that it is not independent. The metropolitan unemployment rate is not independent of the region. Well, let's assume we want to test this for 5% level of significance. So now we have to first generate the observed frequencies table, then we can set up the expected frequency. But for that, we're going to have to use pivot table. So we start with highlighting our data. So the entire data set, 2 rows, the entire data set, 2 columns with the column labels. And we'll go to pivot table. Okay, now we're going to set up the pivot table in the existing worksheet somewhere around here. And then we'll copy it over to the place where we want it. Okay. Now we'll put the region as the row label for the different regions. Unemployment rate as the column label. And we will do the count for regions. This is make sure that it is count. Now we need to group the unemployment. So click one of the unemployments and then right click and say group. And let's say we want to start with 5% unemployment rate going up to 9% unemployment rate in increments of 2%. Okay, so that's our pivot table. So now let's highlight the entire pivot table and we will do Control X for cutting the pivot table and then moving it over here and then Control V. Okay, so now we have the pivot table set up. Okay, let's do some formatting. I'm going to change the labels now. Instead of count of region, say observed frequency or just simply frequency. F sub ij. Instead of row labels, we'll say region. instead of column label, we'll say unemployment rate. And I want to merge and center this text so it'll cover all the categories. So that's our observed frequencies, and we have the totals. So expected frequencies, we'll use the formula row total times the column total divided by the grand total, and we have to use absolute references judiciously. So here column should be absolute referenced, not row. Here I'm going to type the cell addresses. So F13, here the column should be absolute referenced, not the row, times B18. Here the row should be absolute reference, not the column, divided by the grand total, which is in cell F18. Here both should be absolute referenced. Now we'll copy. Now do the row sum. Copy that row sum. Do column sum. And copy that. Now the row sums and column sums correspond with the observed frequencies. Now we'll set up the chi-squared computations, which is observed frequency minus the expected frequency squared divided by the expected frequency. B13 minus B22 squared divided by B22. Copy. We can set up the region and unemployment rate row labels and column labels by simply copying from there or setting up formulas. I'll set up formula A13, copy that, and then B12 and copy that. Do the same thing here. chi-squared test statistic is sum of all of that. Number of rows, count A of these. And number of columns is count A. That. Degrees of freedom is n minus 1 times m minus 1. The p-value is chi-squared this dot rt, chi-squared value, comma, degrees of freedom. Now before we make the conclusion, we need to note that the expected frequency, a couple of them are below 5. So there is only 2 of them, so it's not a big problem. But if there are more than few and if they are way different from 5, then that could be a problem. In this case, it's not a big problem. So the conclusion is, since p-value is less than 5%, we reject the null hypothesis. And the interpretation is we have sufficient evidence to conclude that the unemployment rate is not independent of the region. The probability this conclusion is wrong that is type 1 error is nearly 0.